Hi everyone, in this video I'm gonna talk about the calculation of regression line with some simple data sets, right? So when I say simple, it means that the size of our data set is small. Okay. So the topic is calculating calculating the regression line. Okay, so let's write out our regression line. Okay, so y equals to beta naught plus beta 1 x. Okay, plus u, right? So we try to use the variable x to explain y, and this is our error term. That means the information that we do not capture in our regression line. Okay, and then this is our dependent variable, or no, this is our independent variable. And this is our dependent variable. Okay, and then beta naught here, it's our intercept. Beta 1 is our slope, right? Okay, so this is the regression line we have, but then in real life, we don't have all the information, so we have to estimate it, right? So we need to use our data to estimate this, and then estimation version, it's y hat, right? So hat means the predicted value equals to the first version, right? Beta naught hat plus beta 1 hat x. Okay, and the u is not here anymore because we already used up all our information. We don't know the error term. We don't know the parts that we haven't included yet, right? So the u is gone. Some people write it this way, and then some people y hat equals to a plus b x, right? Also works. So what's important here is that there's no hat on x value, because x is the values that we observe, right? So these two are not the predicted value. That's why we do not put the hats on them. We only put the hats on the predicted values. Okay. Now, to calculate this line, we need to find a and we need to find b. The way we do it is we first find b and then we find a. So slope of, say, y hat, right, our line, our prediction line or regression line, this equals to, or this also equals to the value b. This equals to r times s standard deviation of y over the standard deviation of x. Okay. And what's r? R is our correlation value. So r equals to covariance of xy divided by standard deviation of x times standard deviation of y. Okay. So let me just do an example and we can solve it together and see how we get the value b and the value a. So example, it's height and weight, right? So we want to see how weight can affect height, right? So height 62, 66, 68, 74, and then 120, 140, 180, 180, right? Each pair represents a person. As you can see from here, the sample is definitely small, right? And then when we have larger sample, we do not calculate by hand, because it gets really difficult and really tedious. So we only do this when we have a smaller sample size. So the way we solve this, one good way is to write out all the values that we need, and then we use those values and plug them into the formulas. So let me start by doing this. So the height, 62, 66, 68, 74. And then with this, the average height is 67.5. The weight, 120, 140, 180, 180. The average is 155. Okay, and then the next set value we need is h minus h minus h bar. Okay, let me not do square first. I will do square later. So it'll be minus 5.5, minus 1.5, 0.5, 6.5, and then let me continue on this side here, and then h minus. Okay, now square these values. 30.25. Basically, it's negative 5.5 squared. We'll continue. 2.25, 0.25, 42.25, and also sum them up, right? Instead of taking average, I want to sum them up because it'll be useful later. Okay, so we're done with the H. We need to work with the W. And we'll put a line here to separate them. W minus W bar minus 35 minus 15, 25, 25. Okay, and then I'm going to do W minus W bar squared will be 1225, 225, 625, 625, and down to sum it, 2700, 2700. This value, this value, this value. Okay, next, we need them to be multiplied. We need this one and this one to be multiplied for our calculation. Okay, so the next value we need is h minus h bar, w minus w bar. So this one's 192.5, that 22.5, 12.5, 162.5, and then again we're going to sum it up. Sum is 390. Okay, so I think we have all the values that we need. Okay, so let's do it. The first value we need is the covariance of h and w. Okay, so h and w, and this equals to the summation of hi minus x bar squared wi minus w bar, which is this value, 390 divided by n minus 1. So we have n to be 4, right? We have 4 people, so here's 4 minus 1. So here we get 390 divided by 4 minus 1 is equals to 130. Okay, so that's the first value, and then we want to calculate the standard deviations. So standard deviation of say h, that's equals to square root summation hi minus x bar squared divided by n minus 1. This goes to square root 75 over 3 equals to 5. Basically, we got some here. So this one's value. Okay, and then let's continue. Okay, next one we need is the standard deviation of your weight. That's equals to square root summation wi minus w bar squared over n minus 1. That's equals to 2700 divided by 3. Take the square root. That's equals to 30. Okay, so I think we're ready to find our correlation, the Pearson's R. So Pearson's R equals to covariances of WH, the standard deviation of W times standard deviation of H. This equals to 130 divided by 5 times 30. This is multiply. This equals to 0.866 or 67, right? Let me just, this is our Pearson's R. And then, what's our slope of y hat? The slope of our regression line. Okay, so our slope of our y hat, right, which is b, so b equals to Pearson's R times standard deviation of weight over standard deviation of height, right? So this equals to, let me make sure it's correct. No, here should be H. So what I want to do here, I want to use, so here should be weight and should be a height, right? So basically I'm using height as an x variable and W using y. This is y and this is x, right? Okay. So, I should be more clear at the beginning, but let's be clear from now on. Right. So this is 0.867 times 30 divided by 5, that's equals to 5.2, and that's our b, right? That's our slope. We have our slope, now we need to find our a. Okay, so find our intercept, which is a, right? Intercept. So one fact is that regression line must pass x bar and y bar, right? So regression line must pass the average point, x bar and y bar. Which means that if we have h bar, and w bar equals to 67.5 and 155, and if this is true, then y bar equals to a plus b x bar. Because on this line, the mean values point, they have to be on the line. So that's the fact. So we're going to use this formula here. And we just plug in. So I have 155, which is y bar, w bar equals to a plus, we know b is 5.2 times x bar, which is 67.5. And if we do the math, a equals to minus 196. And then we got a regression line. Regression line is y hat, the predicted value equals to the intercept, negative 196 plus 5.2x. And this is our regression line. And this video shows you how to, when you have a simple sample, that's how you solve for your regression line. So in real life, since our data point, it's our data set or our sample size is huge, pretty big, we usually don't do it by hand, but then for the purpose of this course, we will learn it, how we come up with the value b and we come up with the value a. Okay, very good. This is where I want to stop for this video, and I'll see you in the next video.